One idea that's really important for you guys to know at this point is basically just the model of the Earth and the plates that exist on Earth. You guys did this when we had a sub. You actually went through and did the models for Earth's plates, but some of you were actually kind of representing it the wrong way. Not that it was your fault, it was more just lack of good instructions. But basically, when we're looking at a model of the Earth, the racquetball is actually representing more of the mantle and the core of the Earth, right? Some of you were actually thinking it represents the oceans, but it doesn't. So if you pretend that the racquetball is the mantle, we have Earth's plates covering that mantle. So the Play-Doh is going to represent Earth's plates. Now we kind of have to start by having one plate and just kind of forming it around the mantle, because that's basically how this kind of works. Now, of course, we do not have major gaps in Earth's plates, so we have to make sure that we kind of seal that off completely. So that's kind of what I did here. Right, so I went through and I sealed it. So this would be representing, the Play-Doh would represent kind of the plates that exist on Earth. Now, do we have just one plate that exists on Earth? No, we have many different plates. And these plates are composed of many different sizes and shapes. So I'm just kind of, again, I'm not going to create gaps because we don't have major gaps in the plates, but I'm just going to kind of make up some plates. Now, yours do not have to be like Earth's, because I am not going to spend my time doing that, so I do not expect you guys to. Right, but the important thing to kind of realize about the plates that exist on Earth is kind of like this big giant puzzle piece. You know, the different pieces of the puzzle represent Earth's plates, and they are many different shapes, many different sizes, and more importantly, that all of these plates kind of come together to basically make the surface of the Earth. And we don't have major gaps or anything in between them. Let's seal that piece in. All right. So then after this point, another idea you guys had to represent was looking at the different elevations on Earth. So we have some areas, for example, like along the plate boundary, where we get volcanoes, or maybe we also get mountains. So we notice mountains that can occur, or maybe this is like the mid-ocean ridge, right? So we can get these mountains that occur. And so those are simply just looking at different areas of elevation. Those can occur along the plate boundaries, but we can also have them occurring like in the middle of a plate. This is where we can see them taking place too. Or they can occur along the edges of continents. We see them, you know, and with continents can be, so if we just kind of make one area flatter, because we know that really the oceans are just looking at lower elevation areas where the water just hasn't filled. So if we're looking at this here as being the continent, this is being the ocean basin, you can have mountains that occur here, but then you can also have mountains that occur in the oceans too, right? So that's kind of looking at the model that I've been showing you guys in class, right? So this is going to include more of the oceans, is going to be this area. I don't have the water on there, but we really don't need it. But you can have mountains forming in the oceans like the mid-ocean ridge, and you can also have mountains forming on the continents. And we know that the only thing that defines the ocean floor versus the continental floor is just simply that there's water on top of the ocean floor. Right, we've looked at this idea before. With the plates, we also have this idea of thickness, right? So we looked at this yesterday as well. So we know that oceanic crust is thin because it is just simply lower elevation. And we also know that continental crust is thick because it has areas of high elevation. Okay, another idea that I'll bring up to you guys, and I'll try to do this in a little more organized way, but we also have with oceanic crust, even though it's thinner, it's actually more dense. Okay, why would oceanic crust be more dense? when it's thin. It doesn't really make sense if you think of the idea of density. And when you have water on top of the oceanic crust, it's going to become more dense because the water is going to fill in those spaces, right? The water is going to add more mass to that crust. So even though it's thinner, it's still going to be more dense because of that water, right? And then that continental crust, even though it's thicker, is actually going to be less dense because it doesn't have water adding more mass to it. The idea of densities are important when you're trying to understand how especially continental to continental convergent plate boundaries work, as well as the continental to oceanic. So it will make a lot more sense if you understand densities there. So we'll look at those ideas next.